You ever drive through an intersection and wonder, how do they decide which of these to fix first? Well, it turns out it's not as simple as just counting crashes. Let's dive into this because it's a fascinating statistical puzzle, and honestly, it has life or death consequences. Okay, so put yourself in the shoes of a city planner for a second. You've got just enough money in the budget to fix one intersection this year. Just one. Which one do you pick? It's a huge decision, right? Because this isn't just about easing traffic. It's about trying to prevent the next horrible accident. And believe me, the stakes for getting this ranking right are just unbelievably high. We're talking about a massive human and economic cost that makes this a critical decision for pretty much every city out there. And if you want to put a number on it, just look at this. Even way back in 2008, the estimated annual cost of car crashes in the US was a staggering $150 billion. And that's not just car repairs, that's lost productivity, medical bills, the whole shebang. So yeah, finding the right intersections to fix isn't just a nice thing to do. It's an absolute economic and social imperative. So, how do you find them? The most obvious way, right? The thing we'd all probably think of first is to just count the crashes. Add them all up for each intersection and rank them. The one with the most crashes, that's got to be the most dangerous. Simple. But as you're about to see, that simple logic, well, it can be dangerously wrong. So let's really dig into that idea. Just because an intersection is super busy and has a high number of crashes, does that really make it the worst one, the most dangerous? Take a look at this. This is the top 5 list for Iowa, based purely on that simple crash count method. And, at first glance, it kind of makes sense. The top spot had 165 crashes, the fifth had 140, and just look at the daily traffic numbers. We're talking tens of thousands of cars a day. So these are definitely major, busy intersections. Seems pretty cut and dry, right? Case closed? Not so fast. Okay, so we all agree traffic volume matters. So maybe a fairer way to do it is to look at the crash rate, the number of crashes per car that goes through. That should level the playing field between busy and quiet intersections, shouldn't it? Well, just look at what happens when you do that. The list is completely different. The new most dangerous intersection had only one single crash in 7 years. So how is it number 1? Because it gets like 2.5 cars a day. A single fender bender on some forgotten back road suddenly looks like the most dangerous place in the entire state. See, this method is just as broken, just in the complete opposite way. And this really gets to the core of the issue. Method 1, just counting crashes, is totally biased towards the busiest places. It's like saying a giant city hospital is the worst hospital just because more people die there than at a tiny rural clinic. I mean, of course they do. They see thousands more patients. Then method 2, using the crash rate, is biased towards the quietest spots, where one unlucky accident creates this crazy high rate. Neither of these methods helps us find what we're actually looking for, the intersections that are unexpectedly dangerous for some reason. So if both of those common sense methods are flawed, what's the answer? Well, it all comes down to making a fair comparison. We have to figure out a way to compare apples to apples. And the solution the researchers came up with is actually pretty brilliant. They grouped similar intersections together into what they call domains. So think about it. Instead of trying to compare a massive 6-lane intersection in the middle of a city with a little 2-lane stop sign out in the country, you group them. All the big urban intersections go in one bucket, all the rural 2 lanes in another. For this Iowa study, they sorted over 160,000 intersections into 162 of these different domains based on stuff like road type, number of lanes, location. You got the idea. Okay, so once you have those groups, you can build a much smarter statistical model. And the key concept here is that the model borrows strength from all the other intersections in the same group. Basically, it looks at the entire group of, say, 4-lane suburban intersections to understand what normal looks like for that type of intersection. This helps create a much more stable and accurate picture of how safe any one of them should be, and it smooths out all the random statistical noise. And this is where it gets really cool. Because this smarter model doesn't just spit out one number. It gives us 2 incredibly powerful pieces of information. And when you put them together, they reveal the places that are dangerous in a way you'd never expect. So, on one hand, the model calculates the expected number of crashes. This is the baseline, what you'd predict for an intersection like this, given its traffic, its number of lanes, and how its peers in the same domain behave. But then, and this is the game changer, it calculates a surprise danger score. This is a score for how many more crashes a place is having than its nearly identical twins. That is the hidden risk factor we've been searching for. This surprise danger score is everything. The researchers call it the kappa value, but let's just stick with surprise danger. A high score here doesn't just mean lots of crashes. It means this intersection is a major outlier. It's performing way, way worse than it should be. And that tells you the problem probably isn't just the amount of traffic. It might be something you can actually fix, like a blind spot or confusing signals. And now look at this. This is the new top 5 list ranked by that surprise score. It's completely different from that first list we saw. Check out the intersection at number 2. It only had 27 crashes. It would never have made it onto a list based on total accidents. But its surprise score is huge, which means it's failing badly compared to similar intersections. This is how data uncovers the hidden dangers that were right under our noses the whole time. So what we have now is so much more than just a better list. It's a whole new way of thinking, a framework for making smarter, more flexible decisions that can actually save lives. But it gets even better. The model doesn't just give you one static list. It actually runs thousands of simulations of what could happen in the future. In every single one of those simulations, it re-ranks all the intersections. And from all that data, it can calculate the probability that a specific intersection will end up in, for example, the top 20 most dangerous spots. And that is the real magic right there. It's not just about which one is number 1 today, it's about confidence. Now, a city planner can see which intersections consistently pop up as being dangerous over and over again in all these simulations. An intersection that has a 99% chance of being in the top 20, that's a sure bet for your limited funds. Way better than one that only shows up there 30% of the time, right? So the big takeaway here is that we're moving away from a single, rigid, and frankly misleading list. What planners get instead is this flexible, powerful toolkit. They can literally say, okay, show me every intersection that has more than a 70% chance of being in the top 50 and make incredibly smart, data-driven decisions about where to spend that money to save the most lives. It's pretty amazing when you think about it. Just by looking past the obvious numbers and asking smarter questions, we can uncover these hidden patterns that have a huge impact on people's lives. And if this kind of thinking can make our roads safer, well, it just makes you wonder, what other life-saving secrets are just waiting to be found in all the data that's all around us?